What's up, everybody? In this video, I'm going to show you how to make the Mario theme song using Python from scratch. That being said, let's just jump right into it. Alright, so here we are in VS Code. And before we get started coding, let's see what we're going to produce. So I'm going to click this song.wav file and have a look. Alright, cool. So we're going to end up producing that. That definitely brings warm memories for me, as Mario was the first video game I ever played. So definitely, and it's definitely still a game I enjoy playing to this day. So I was happy to be able to build this using Python, and I'm happy to show you guys how to do it as well. In the process of doing this, we're going to learn some kind of interesting things about how to program in Python, kind of with music, kind of how those two interact. We're not going to do anything fancy, so we're going to use some of the more basic, packages for working with music. There's definitely fancier things out there, but I wanted to kind of get started with some of the, maybe some of the built-in packages that Python provides. All right, so let's start by seeing what kind of packages we're going to need for this little project we're working on. So we're just going to start out with these three imports, and the first one's going to allow us to write the music to a file. So it's a Python built-in, nothing we have to pip install or anything. And it's going to allow us to write this song.wav file. Now, you may not be familiar with whatever a .wav file is, but it's really just it's a format for for music, but it's not really compressed like a MP4. So it takes up a lot more space on your computer to store. So it's not really used for everyday music or sounds, because you're going to want to compress it for efficiency. However, this is the uncompressed format for which you can kind of store your sound, store your music, that kind of thing. So we're just going to work with that for simplicity. We're not going to worry about compression or anything, because we're not building, storage isn't going to be an issue for us. We're not doing too much here. That being said, those are the three imports. I'm going to go ahead and run them. They're going to run over here. They successfully ran. I'm using Python 3.9 if you want to kind of use the same version of Python, but it shouldn't matter too much as long as you're using something relatively modern. I'm going to define this frame rate here. This is kind of just the standard frame rate for written music. You could use something a little bit less, but we're going to go ahead and work with this. It turns out that there's actually some pretty interesting math as to why we picked this number, but the human ear can only actually pick up so much in terms of sound. So if you use a frame rate that's too large, it actually doesn't even really make a difference in terms of what we as humans can hear. So there's some sort of limit in terms of how high it actually matters in terms of this frame rate, and we're just going to pick something pretty reasonable. So now I'm going to actually get two more functions here. I'm going to put them here. So again, we're not going to have to worry too much about these, but the key is that these are actually what's going to write the music files. So there's this encode, which I'm not going to get too much into it, but basically we're going to produce our music as basically as floats in Python. So basically as just numbers between, say, like 0 and 1, or maybe -1 and 1. And we're going to convert those floating point numbers to integers. And that's what this is going to do. And in fact, we're not going to just convert it to integers. We're going to actually convert it to bits and bytes, because that's actually how you're supposed to interact with the wave files. I'm going to go ahead and change this song to Mario so we don't overwrite our previous file. So then this is actually how you end up right into writing out the file. We called it play, but it could also be called something like write file. There's a couple things. Set channels to 1, that's fine. Set sample width, that's some technical point. That basically means we're going to write 2 bytes for every sample, and so on and so forth. So now, what do I mean by sample? So basically, we're thinking about our song over time, and we can't actually plot like, every single point in the song. So you actually sample your song many times per second. So here I'm sampling like 44,100 times per second. So that's quite a lot. Seems like a lot. And at the end of the day, that's going to be what's actually stored in this .wav file is all of these different samples of our song. And we'll see more about what that actually is as we proceed forward with this project. But yeah, so these two helper functions are going to help us to write the file. And actually, the only place we use the encode is here, and we're not going to use it for the rest of this project. So it's just a way of encoding our eventual floating point numbers into these wave files. That being said, let's go ahead and actually start making some music. So I'm going to actually copy another function here. So we're going to call this try. And so there's a nice function here, and this is going to return another function. So that's pretty interesting. Let's go ahead and run this. And actually, let's run the previous two functions that we have as well. This one and this one as well. And yeah, so these are, so this try function is a way to produce single notes, it turns out. And we're going to have a look at this a little bit in detail right now. Okay, so I went ahead and created this code to plot this try function. So let's go ahead and run it, see how it looks. Make this a little bigger so we can stare at it. So this is what this try function looks like. You can see the x-axis goes from 0 to 100, and it looks like a triangle. And in fact, if I made it, so let's go ahead and make this 2 times bigger, like this. Run everything again, you can kind of see that it repeats. So what's going on here? So it turns out that the period, the way I have it configured, is 100. And this is because the frequency is 440. So it's roughly 100. It might not be exactly 100. It's going to be the frame rate divided by 440. So that's around 100. And it's just going to be a triangle that repeats every around 100 units on the x-axis. So this is the try function. Now you might be wondering, why are we using this function? To be honest, there's several other choices for how we could choose this function. For instance, we could just choose, say, a sine wave that looks somewhat similar to this. However, we're just going to use this triangle function because it kind of sounds nice, and that's what we're going to go with. But you can think of this as a sort of approximation to maybe a sine wave or a cosine wave, something like that. So this is what we're going to use, and it turns out that this is basically our building block, how we're going to start inputting certain notes. Just like if you played something on the piano, if you hit a key, this is going to be exactly the kind of the digital analog of hitting that key, is using this function to create notes. So let's go ahead and get started on how that actually works. All right, so let's start building the beginning of the song. So first I'm going to set the octave to be 0.5, and I'll explain a little bit what the octave means in a second. We're going to get the E frequency, and that's something, again, I'll explain in a second. We're going to set it equal to that, and that's a very specific number for a very specific reason. And we'll also get this one. So this is actually going to be the E note. I have this 5 here, which again I'll explain, but I want to actually play the note first. So let's go ahead and get started with that. Next up, I'm going to define a function that just returns 0, and I'm going to call it P, and the P is going to be shorthand for pause. Let's actually write that here. P is short for pause. So that's okay. So let's run all this. Sure, it's all ran. This one we can get rid of. Maybe make this a bit smaller here. That ran successfully. Now we're going to go ahead and actually start creating the Mario song. So I'm just going to copy the first few notes into here. So like this. And those are going to be the notes. So this is actually how the Mario song starts out, which is kind of interesting. Now the next thing I'm going to do is define a couple helper functions, which again I'm going to explain. So basically we're just going to see how all this works together. And then in the end, I'll come back and explain like, hey, this is what's going on with each of these things. But I want to see exactly how it works first. So we're going to play this both, we're going to, run this both function. We're going to have this note function, and I'll explain what these are in a second. And then we're going to go ahead and write this function called create song, which I'm going to copy from another screen. And I'm going to come back and explain all this, so don't worry about it too much. But with all these helper functions in place, we can finally create our song, using these very few notes. So let's go ahead and do that. Okay, so here I've created my song, so let's go ahead and create it. And then here I'm going to play it, which actually just means save it to a file. And if we go here, we see we have a Mario file. Let's go ahead and see how it sounds. So that's the very, very beginning of the Mario theme song, and we have it all situated here. So this is actually kind of how we're gonna, program the Mario song. But let's go ahead and kind of take a step back and see actually what happened through all this. All right, so here we are at a chart where we're getting some of these tricky numbers from. So you can kind of see at the top, they have all these different octaves. It says music note to frequency chart. And on the left, they have all the different notes you can have. So actually, basically in each octave, there's a different frequency at which the note plays. So just to get an idea of where I'm getting this from, if we go back to the VS Code, and you see I said E frequency is equal to 329.63. Now going back here, you see I say 329.63. That's exactly where I'm getting this number from. Is I'm taking it from octave 4, right in the middle. They say a piano middle C, so that's really where you typically start start your right hand when you're playing the piano. Anyways, I'm getting that number exactly from here. So that's where I'm here. The way I have it situated is that I actually made that one to have octave 0.5. That's kind of up to whatever you want. But the point is you can actually see, like, let's go back to that E thing. So 329.63. If I go to the next octave, it actually doubles the frequency. And if I go to the previous one, it actually halves. So that's how you actually go from one octave to another when the note is fixed, is you either halve the frequency or double the frequency. So that's really where this E frequency is coming from. That's why I have this octave thing. So the way we have it programmed is I can actually easily, just by changing this octave variable, play this song on different octaves, which is a pretty convenient way to do it. So again, this E5 note is actually just going to be basically, it's going to be that the triangle function I showed you earlier, except for at a different frequency. All right, so here I'll show you kind of a funny graph. So I have the same thing, except for this time I just make the x's vary from 0 to the frame rate. So this would be kind of simulating an entire second. I'll go ahead and run this. And you can kind of see it's kind of fills up the entire screen. So really what happens is it's really too big. Like the frequency, it repeats too many times to really get a sense of it in terms of like looking at it as a graph. If I do divide by the E frequency here, you can kind of see a little bit more like we did earlier. And that it kind of starts at, starts at negative 0.3, it goes up to 0.3 and then comes back, and then it'll end up repeating every around maybe 100, between 120 and 140 units. Basically every 100 and the unit is actually the frame at the end of the day. So this is really this E note being plotted, and basically it's just gonna stretch out or squish this triangle depending on the frequency. So that's what's going on with the E note. It's basically just this triangle function, but it's either going to be stretched, going to be dilated in some way, in the sense that it's going to be stretched or compressed. That being said, we're going to go back to our Mario function and kind of see what else we've done. Here we have this P of T. This is just to pause, which is pretty frequent in music, that you're not just be playing notes all the time. And the way we have it programmed is we're just going to return 0, so it's just going to do nothing. Now here we have our notes. So this is again the beginning of the music. All right, so where did I get these notes from? These E notes that began the Mario theme song? Well, it's actually just coming from the sheet music for the Mario theme. Here's one such example of of this thing. So you can actually just read the notes off from this sheet of music. Personally, I'm not an expert at reading music, so I had someone help me to make sure I got it kind of right. So that's that's due to my wife actually. So you thank her for actually transcribing some of the music, and we're going to transcribe a bit more of it later on. So that's really how you just go and get the notes. And then of course you can get it for any music you're interested in, or if you want to even create your own music, that's something you can do. And something DJs or other people may actually do. So these are the notes. Now, I created this both function, so that's something we'll see later. But this is actually a convenient way to combine notes at different time intervals, or even at the same time interval. We'll see. So you can see that you take a function f and g, and you just return f plus g. So you might have it. For like maybe an eighth of a second, f is playing a certain note, and then the next eighth of the second, g is playing a different note, and this will combine them. If you haven't seen it before, in Python, there's this lambda function, and this is a kind of a Python built-in that lets you create functions at in one line of code. So that's something to kind of dwell on for a bit. So we are really working with functions here. Like the pause is going to be represented as a function. This try is represented as a function, which I've actually still have the graph on the right here. So everything we're working with in terms of these notes are functions. The x-axis is going to be time. And as you can see, I denoted t here. And the y-axis is going to be something called displacement, which we're not going to talk about too much. But that's going to be how we're actually working with these musical notes, is we're going to actually think of them as Python functions. So basically, f and g are both going to be functions, and we're going to return a function. This is just something that's kind of nice with Python. It's not actually, working in every language, that you can just, input functions into other functions and do all sorts of things like that. So there's a whole theory about, whether that's, being able to do that, and, something called like higher order functions, if you want to kind of Google and get interested in that. But again, we're not going to get into too much detail on all this stuff. Just kind of give you what you need to get going. And you can look up stuff more on your own if you so desire. This one actually creates a note. So the first argument is going to be a function, and then we're going to have a start and an endpoint. And basically, there's just some custom logic here to make it so that it plays this function, plays this note, or plays maybe a chord, as we'll see later, along this time frame. There's this nice keyword argument fade, which we're not really going to adjust at all, but it just makes it sound a little more pleasing to the ear if we just add a fade towards the beginning or towards the end of the note, so that it's not kind of a sharp cutoff, which can sound a little abrupt if you're just kind of listening to the music. So that's why we have this fade. So basically, this note, you input something like your, basically one thing that might be input is this E5. This E5, you might actually create the note from it. And the note, again, it's going to have a start point, an end point, and all that. And I have some logic to create the notes. Actually, really all we're going to see for now is this one. I have some other logic for later when we do some more complicated stuff. But basically, my song starts off as the 0 function. And then Z is going to represent kind of the time. And basically, I'm just at every time step, I'm adding the song to the next note. And then adjusting the time accordingly. So this is kind of assuming that all of the notes have length an eighth of a second, which, actually for the most part, they do have an eighth of a second, but, it's not always the case that every single note's going to have an eighth of a second, which is why I have some kind of custom logic here to handle the case when that's not. But at least when we're starting out, that is the case for the first part of the song. So this basically is a convenient way, we're working with Python functions to create this song, kind of iteratively. We combine the song, which contains maybe a bunch of different notes in sequence, and we add it to an additional note that we created. So then once we do that, once that is all set up, we're able to play the song. Well, we're able to create the song, first of all, in this iterative process, and then actually play the song. And we keep track of this total time so that we can, when we're right into the file, we know how long we're going to do it for. And I just, kind of was lazy and I just did the total time as an integer and then I added 1 just to make sure we get the entire song. All right, so with that being said, we're kind of ready to do the more complex stuff of actually building out the Mario song. So we're going to need a lot of variables. So far, we've only had a few. So I'm going to copy a bunch of these, basically just configuration, and I'm going to put it right here. So these are all the different frequencies that we're going to need for this song. And again, I'm going to put the link in this code, which, you can find the code in the description, the link to the code in the description below. I'll put it in a comment. So these are all the different frequencies we're going to need for this song. And they're all coming, again, they're all coming from this link here, which we discussed earlier. Let's pull it up. Let's see. There it is. Not this one, but this one. So all the different frequencies you can read here. And again, this is just how you create the different notes. Okay, so those are the different frequencies. Let's go ahead and run them. Gonna get rid of that one and scroll down. And it did in fact run. You can see here. I'll kind of make this smaller. And next up, we're gonna actually need to create all the different notes. So there's a ton of them. And I'd be interested to see if you guys have come up with a better way to do this. But I just kind of hard-coded all the different notes we're gonna need right here. So let's go ahead, click here. I'll press Shift and click up here. I'll highlight everything. I'll kind of run it. So now all of these different notes are in the in our file. So I'm basically assuming I'm starting at the 4th octave. And so this like G4 represents the 4th octave. And if I want to go to say G5, I just have to multiply the frequency by 2, as I discussed earlier. We go back to here. The G in the 4th octave will be 392. That's going to be the hertz. That's going to be the frequency. And if I want to go to the 5th octave, I just kind of double it. So that's why I'm multiplying by 2 if I go from G4 to G5. And I have all these different notes, which I think I just ran, if I'm not mistaken. So then, now that we have the notes, the last thing we have to do is actually input the song. So I'll go ahead and do that. Instead of this here, I'm going to put this. And I think if I get rid of that, let's see. So then click that one. Oh, we'll fix that chord error in a second. We click, well, we can't run it now. So the last thing we're going to need is that we haven't needed before is a function to create chords. I think, in fact, we could have used the both function that I made earlier, but I wanted to kind of introduce something a bit more general. So we're going to scroll up right around where we create the both function. Let's see, where is it? Here it is here. So let's go ahead and make this chord function. So this chord, again, it's just a way to combine a bunch of different notes at once. So it's similar to the both function, but instead of having just 2 possible notes, you can actually have as many as you need. Let's go ahead and run this. And in fact, let's actually move these since we're using the chord there. Let's kind of move these up here. That might be a little bit more pleasant. So then it doesn't seem like we have any syntax errors, which is nice. Let's go ahead and run this one. So we have all these. So let's click here and then let's do down here. Shift enter and enter that. Cool. So now we have all our notes. And now everything's the same. We can run this. And it's going to take some time to run because, well, you can actually make this run quite a bit quicker if you just decrease the frame rate, but I'm not going to do that. So we're using a pretty large one. If you just maybe did like divided by 4 here, it would probably run, it sounds about the same to you, but I want to do it, as good as possible. So that's why it's taking a little bit longer to run, which is completely fine. So while we wait for that, so notice that there's all these different notes here. I've created this notation here, and this is just kind of a simple way to basically introduce notes that last for longer than 1/8 of a second. So here it's going to be 1/4 of a second, 2 times 1/8 of a second. And again, this was just kind of a way I introduced it. There may be cleaner ways to go about it, but I just wanted to get something to get this Mario song, which was, a nice song for me. So let's kind of see how this sounds. Cool. So it kind of works. You can kind of see there's a pause at the end because again, I was a little lazy in terms of the timing, but it sounds pretty good. If you have a really keen eye, you might actually notice it's not completely perfect, and that's because we're actually missing the entire bass clef. So let's go ahead and add that. It's not actually too hard to add, it turns out. Well, the hard part is to transcribe the notes, which we're gonna go ahead and assume that it's been done. So let's go here. And instead of notes, we're going to go here. And I just added a bunch of stuff. I'll show you what I added up top. I added this variable called bass notes, which we're going to go ahead and run. So these are all the different bass notes. And again, you can get this all from the sheet music. And I'm not the world-leading expert at reading sheet music, so I had someone help me do that. But that's something you can go ahead and do. And we're going to have to change a little bit the logic in terms of creating the song. So I'm going to go ahead and highlight these and comment them out and add these. So you can see we're kind of creating two songs at the same time. They both hopefully have the same total time. And the final song we're just going to combine. So luckily, the way we've programmed combining the song with the bass is actually not too bad. We're going to go ahead and run this because it's going to take a little time as it did last time. And so once you get, the bass in there, that's kind of a nice sounding Mario theme song. So we're going to kind of wait for that to run. But yeah, so this is kind of one way you can start, actually creating music in Python. So it's kind of pretty interesting. I had some fun kind of making this. Really, at the end of the day, we're just using these notes as building blocks and then combining them in some way. I will say I got this. I got a lot of the idea for this video from a lecture I saw on YouTube. So I'll link that in the description below if you want to kind of go to the original source. In particular, I got this encode function and this play function pretty much as is from another YouTube video, and also this try function. I just kind of actually took it to the extreme and kind of made it, actually created the Mario song. So let's go ahead and see how it sounds with the bass. Cool. So that's the Mario theme song in Python. So I hope you enjoyed this this video, and yeah, so I'll link the code in the description below just in case you are just interested in kind of continuing it. And if you make any changes that kind of are interesting, like for instance, there's more to the song you could program for sure. So if you want to go ahead and do that, just feel free to let me know. I'd be interested to see in what direction you might take this this line of this approach to creating music in Python. That being said, I think that's it for this one. So I hope you liked it, and I'll see you in the next one.